In this tutorial, we are fundamental topics of AWS. Okay, so what I want to do is I'll go ahead and build a VPC from scratch, and I'll try to cover the different aspects of it so that you understand that how does it work. Okay, fine. So let us get started. I'll switch to a particular region. Let us say North California, and okay, so you can see, AWS recently changed the whole UI. Now you can, because there are a lot of services, you can go ahead and just search for it, even and click on that. Now the VPC dashboard comes up, and we'll see that there is one VPC already there, so which is the default VPC. AWS gives you a default VPC in every region. It is just for the purpose that when you are getting started and you don't know how to create a VPC, there is a VPC for you for default. By default you can go ahead and just quickly create EC2 instances in that particular VPC, but do not use this default VPC for your customer deployments. So our intention is to learn how to create a VPC. Alright, so let us go and click on your VPCs. I'll say create. Now I can go ahead and give it a name. Let me call it my VPC, and I need to give a CIDR block. So let's say I'm giving 10.0.0.0/26, and I'm keeping the tenancy default. There's another tenancy available as well, dedicated. If you choose dedicated, then you will be able to launch only dedicated instances or dedicated host instances in this particular VPC. We don't want to do that. So if you are choosing default, then you can launch all three types of EC2 instances within that, which are shared, dedicated instances, and dedicated host. So I'm going to keep it default and move forward. I hope you understand what this particular CIDR block means. It represents a range of IP address. If we want to understand that what how to calculate that, I can explain you that. Um, so if you see a range of IP address like this, it represents a range of IP address where the start would be whatever you see before the slash. And in order to find out how many IP addresses are there in this range, you do a simple calculation where you do 2 to the power of 32 minus, you put the number which is after the slash, so like this. So which becomes 2 to the power of 6, right, which is equal to 64. So we have 64 IP addresses in this range. If the starting is 10.0.0.0, and is going to be 10.0.0.63. Simple, right? So we have totally 64 IP addresses in this particular CIDR block. And what we are going to do is we will divide it into 4 subnets, right, of 16 IP addresses each. Okay, fine. So we'll go ahead and do that. I'll say create. Okay, so our VPC is created. Next, we go ahead and divide this VPC into subnets, right? Now understand that VPC exists into a particular region. You did not give any availabilities on there. One VPC cannot span across regions. So I have created this particular VPC in North California region. I go further, and now there are I go to the subnets. So these are the 2 subnets which are there of the default VPC. I will go ahead and say create subnet. I'll give it a name. I'm going to call it private A, because I will be creating it in the availability zone A, and I'll choose my VPC. And now we need to give it a range of IP address basically in the CIDR format. So I already told you that I'm going to divide the 64 IP addresses into 4 blocks, right? Or basically into 4 subnets of 16 IP addresses each. So I'm going to put it like this. Now 2 to the power 32 minus 28 is 2 to the power 4, which is 16. So that makes sense. This particular thing will start from 0 and end at 15. Okay. Alright, I can just filter so that we see only the ones which we are creating now. Okay, if we create one more, private B, and this time the other availabilities, oh, sorry, I'll call it private C, let's say, right? 10 dot 16. So first one was there up to 15, so second one starts from 16, and we put like this. Okay, so following the principle of high availability, we are creating two subnets private and two subnets public, both in different availability zones. Alright, let's go ahead and create two public subnets as well in the same manner. Okay, and we do it in 8 and that. This time 32/28. So the second one ended at 31. So this one is starting at 32, and this one will end at 47, and next one will start at 48. All right. So I call it, sorry, public C. Okay. Right. So with this, all our four subnets will get created. Now remember, if you try to give a CIDR block which is conflicting, meaning if you try to give a range which is already used, then it will give you error here itself, right? Basically, subnets cannot clash in terms of IP addresses, right? Okay, now you can see we have got four subnets created here. You can see the availability zone as well, right here. Now something to remember, we have divided it into four subnets of 16 IP addresses, but the available IP addresses are only 11 in all. This is because whenever you create a subnet on AWS, 5 IP addresses are reserved or kept for internal usage, which will not be available to you. So what are those 5 IP addresses? In every subnet, the first four and the last one IP address, right? So those five IP addresses would not be available to you. All right. Now we move to the next important thing, which is route tables. Now, as you can see, you have one route table available with the VPC which you have created. With any VPC you create, one route table gets created by default, and that is called the main route table of your VPC. You see the main attribute as yes. Okay, I'll go ahead and just rename it. For our convenience, I'm going to call it, say, public RT. Oops, sorry. Okay, I will also create one more route table. So this is going to be custom route table. I'm going to call it private RT, and why I'm creating one public and one private. The public route table is going to get associated to the public subnets and private one to the private subnets. So you can see currently none of them are associated to anything explicitly. So it is also important to understand that if there is no route table explicitly associated to a subnet, the main route table of that VPC will be used for the subnet. So if I don't go ahead and do any explicit association, automatically the main route table, this one will be used for all the subnets, guys. But we will go ahead and do the explicit association now. Also, yeah, all right. So let us go ahead and do that. We can just do it here. Go to the subnet association, press edit. So this one is private. So I'll associate it with both the private ones. Say save. You will see the number changing here to 2 now. Oh, I don't know why it is going so slow. Alright, so this is done. We choose the second one and we do the same here. Now we'll associate it with both the public ones. Okay, save it. So remember that one subnet can have only one route table, or meaning one subnet can have only one route table associated to it. But one route table can be associated to multiple subnets. That is possible. We did it just now. So this both the route tables you see are associated to two subnets, right? Okay. Now we need to go and do some change here, because currently if you see, look at the routes in both the route table, it is same. So there's no difference in the now. We need to make the two subnets public. How when is a subnet considered public? When there is a route available in the associated route table to the internet gateway. Now internet gateway is the entity which allows connectivity from your VPC to outside internet. So I'm just creating an internet gateway. It is a managed service. You don't have to worry about its scalability, availability, nothing. You don't have to worry about it. So I created it. Now I need to attach it to my VPC. See there, only my VPC is coming in the dropdown. That is because only one internet gateway can be attached to a VPC. You cannot attach n number of internet gateways because it is already scalable. Okay, so we go back and we choose the public route table. We go to edit in the routes and we add one route. Now we will send all the internet bound traffic from this particular subnet. You see here the IGW started coming and we save this. All right, so we have accomplished our public route table and it is attached to the two subnets already, which means now both of these subnets have actually become public subnet. Great. So one more thing which we want to do is we come to NAT gateways. Now what is the importance of NAT gateway? First of all, let us just choose that, quickly create it. You need to keep the NAT gateway in the public subnet always, remember. So we'll choose one of the public subnet and you need to give it an IP address. Okay, I gave that. We go ahead and edit the route tables, go to the private one, go to the routes, say edit, and anything which is internet bound traffic that will send to NAT now. So we do this and we say save. Alright, so our both the route tables are ready and it is all association is done. We have created internet gateway, we have created NAT gateway as well. Let us quickly understand what is the use of in NAT gateway. NAT gateway helps all the internet bound traffic which is getting originated from your private instances to go to internet, and then it gets the reply from the internet and gives it to your private instances. Let's say in your private subnet you have got a database server. A database server needs to download some DB level or OS level patches from the internet, so it will originate traffic to internet. And because private instances are not going to have public IP, they can never communicate directly to the internet. It sends traffic first to NAT gateway, and NAT gateway sends it to the internet, gets a reply back, and gives it to the private instance. It just acts as a forward proxy, as you people have in your organization. Now, NAT gateway is also a managed service, so you do not have to worry about its availability and scalability at all. Whenever traffic increases, it will scale automatically. You don't have to worry about it. And we had chosen and placed it in the public subnet, this particular public subnet. That's why you see one IP address got reduced, because NAT gateway is using one of the private IP as well, of course. All right, so we have all this done. So this is how you can create a VPC. You can divide it into subnets. You can size it in the way you want. I've kept it simple here. Based on your needs, you can choose different sizes. You can probably keep public subnets smaller and private subnets bigger, and then place your instances within that. Few quick settings here. We'll go ahead and for the public subnets, we will change one property, which is modify auto assign public IP. We'll make it true, which means this property will be shown when you are launching instances in this particular subnet. So we want that when instances are being launched in the public subnet, they should get a public IP. That's why we are making this particular property as true. And at the VPC level, you can go ahead and select your VPC. You can go ahead and select edit DNS resolution. This is yes already, so it is good. You can also do edit DNS hostname, so that the instances launched in this particular VPC, they get a private hostname as well. All right, so I think we are good with that. I will end this tutorial here. If you have any questions related to VPC, please go ahead and write it in the comment section. You can subscribe and like this and share this. We will go ahead and in another video, I will go ahead and launch instances and will show you how it works between public and private instances. All right, thank you. Have a great time. Bye-bye.